In our daily life, we think an event happened to all the people at the same time. But it is not true when we want to use the constant speed of light. This is a very, very strange world. In this situation, we have a boy and girls. Girls get on the trains. Train is moving to the light with a speed of v. And the source of the light is located at the middle point on the trains. Then what happens we are going to consider. Girls see the light arrive at the both walls A and B at the same times because as I said, source of the light is located at the middle of the trains. Does the boy see the light arrives at the both walls at the same time? Find out if the boys see the light arrive the both end of the wall at the same time. We have to synchronize the clock. Synchronization of the clock is required. It might be possible for a clock to be slow or fast during move to the new location. Synchronization of the clock at each position is required. So we place the clock here. Then we'd like to synchronize this clock with this clock. Then observe how long does it take for the light to come to this point. Because we can easily measure the distance between the source of the light to the observers using tape measures, L. Then we'd like to calculate how long does it take for the light to come to this point. So L divided. Then by using this data, we can synchronize these two clocks. Okay? Then actually we place the number of the clock on the load. All the clocks are synchronized. When end of the wall of the train is passing through this point, we can use this clock. Then we can find out if the boys see the light arrive the walls at the same times or not. Then actually it should be the different arriving times. Boys see the light arrive the wall and B at the different times. The required time for the light to arrive at the wall A and B are given by this equation. Because the wall A of the train is moving to the light, this length is given by B T sub A. And this length is C T sub A. And this length is of course L. So for the light to come to the wall A, is L equal C plus V T sub A. You can calculate. So T sub A is obtained. L over C plus V. So to come to the wall B, total length for the light to travel, Ct sub B. This is L plus B times T sub B. So you can calculate. T sub B is L over C minus V. So for the boy, actually required time for the light to arrive the wall A and B is different. So term of the simultaneous depend on the position of observers. This is a very, very weird world. So if we use a Galilean coordinate transformation, relative velocity is changing. So train is moving to the right. So the ball is moving to the left and the right is different speed. Because of the speed of light is different in this situation, C plus B. When the ball is moving to the right. When the ball is moving to the left, it should be the C minus B. Then for wall A, this is wall A. For wall A, This is C minus B times T sub A equal L minus B T sub A, because the train is moving to the right. These are new positions as we studied. Then this becomes T sub A L over C. For the B, wall B, C plus B T sub B equal L plus B T sub B. So T sub B is also L over C. So in this case, even for a boy, he observed the light arrived at the both ends simultaneously, because the T sub A equal T sub B. In the Galilean world, simultaneous event is observed by everyone. So we have to drop this idea of the Galilean world to accept special relativities. So actually the idea of the relativity is very different from our daily experience.